Hello, hello, hello. Hello, Haripriya. Us. In the last class, we have learned up to here, no? Archimedes' principle, law of buoyancy. Hmm. So this one was yours or? Oh, okay. Hmm. No. Acha, Diva, could you solve all the questions which you have given to me? You have, or you still have any doubts in some of them?
Sir, I was able to do, I think most of them had done.
Most of them you have done, na? Okay then. See, after this, we'll move on to the next concept. Actually, here, acha, could you solve this question? This question I'm giving you. Hmm, this one. Question has come. Options has to come. This one. Can you solve it? Hmm. Just wait 1 second. Pen bar was not coming. Ah, okay, now it's coming. Haripriya, are you getting the idea? Diva, how to solve this?
You have to break it into components.
No need to break into components. See, there are two liquids whose density, one is D1, this is D2. They have given each liquid subtends an angle of 90 degree. That means the total angle, this is 90 degree. Further, if we actually I'm not able to draw properly. If I take this angle, this also is 90 degree. I have not drawn properly, but visualize it like that. Now you have to find out the ratio of D1 by D2. Assume this is air. Here atmosphere pressure is P naught. Here also pressure is P naught. No need to divide it into components. Just you have to apply that law. The pressure Pascal's law I have told you, no? Here pressure is same. Pressure in same correcting liquid at same height is equal by using what you are solving. So either you can take this level. This is same liquid now. Either you can take this level or you can take the bottom level to and equate the pressure on the right limb and the left limb. Got it what I'm saying?
Yes, sir.
Try to do it. This is alpha. So this angle will become 90 minus alpha. This is alpha, this is 90 minus alpha, and this again will be alpha. Right limb will be okay. We'll be able to. This is R. Again R. This is R. Hmm. Which level you will take? It's convenient if you take level 1. But again, it's up to you. Whatever you want to do, you can do. You understood the idea now, how to solve it? Try to do it. Let's see if you're getting the answer or not. If you won't get, I'll solve it.
Sir, could you solve it?
See, did you see? Are you able to see the heights that I have written? R sine alpha,
Yes.
this right part, this R cos alpha, left hand, this and this. So see, what I'm going to do, I have taken the level 1. I'll equate the pressure in the left limb at level 1, left limb pressure is equal to right limb pressure. It's just for showing you. Okay, because that's our law. Same thing you can do at level 2 also, but since I have represented all the calculation using level 1, I'm doing using level 1. Now in the left limb, if we see, the pressure at the level 1 would be P naught plus rho, acha, it's D1, density is D1 for the liquid one, D1 G into R cos alpha minus R sin alpha. This is the pressure in the left limb. Now if you look at the pressure in the right limb, it will be P naught plus D2G into R sin alpha plus R cos alpha. P naught will cancel. G also will be cancelled. They want d1 by d2. So d1 by d2 will be equal to R will take common sin alpha plus cos alpha divided by R into cos alpha minus sin alpha. R will be cancelled. Now divide the whole equation with cos alpha numerator and denominator. You'll get tan alpha plus 1 by 1 minus tan alpha. So the answer you are getting is d1 by d2 is equal to 1 plus tan alpha by 1 minus tan alpha. C option. See, it looked very difficult, na? But it's easy.
I messed it up in taking the heights.
Hmm. Actually, the diagram has to be done more properly. This part I have messed up. This part, this blue part, this line and this line. It actually, it has to look like 90 degree, but it's not looking like 90 degree for me. Here in this diagram, if we extend it, it will look like 90 degree. Like this. This is 90 degree. And again, this is also 90 degree. Diva, understood?
Yes, sir.
I have shown this question because this kind of questions also they can ask. It's a good one. But nowadays the JEE main level has gone down for physics. They're actually asking easy questions, so no need to worry. But they may, because you are preparing for advance, you have to be prepared for tougher one also. It's not that tough. It's a C. You have understood and you have learned the pressure difference due to height. Pressure difference because of the height. Acceleration due to gravity. But what happens when a stationary liquid, stationary container, well, let me draw it first. pressure difference in liquid due to horizontal acceleration. This is our container. Now what happened? We have filled it to this height. Okay, if I say, I can just show it. The left has the top, this has height h. Achha, let me like show it like this. Initially, it was like this, liquid. Now, have you observed it? Observe this kind of thing. Whenever a liquid is present in the container or it is present inside a truck in lorry, container lorry, there, but actually it's fully covered, we are not able to see. But what happens when we just push something, means suppose you have a glass full of water and you just move in the front with some kind of jerk, what will happen? The liquid will come backwards. Yes, observe it.
Yes, sir.
But if you'll stop, it will move forward because it has got a momentum. It will spill out. But once you have started moving, it will move backward. That's what we are trying to observe here. When the same container, what I will do, initially it was in this situation. Now I have given it some acceleration. Let me copy it. Now I have given it some acceleration. And because of this acceleration, what is happening? This is AX or A, say. The liquid will change its shape. Some of the water level will go down and it will come here. It's not necessary that it will go up to the leftmost height, but it will reach up to some height depending on the value of the acceleration. In this case, suppose this height is h, this height is small h. Now our task is to find out what is this difference in height capital H minus small h, and what is this inclination, correct? Because of this acceleration. How we'll do it? Just simple equilibrium. What I am going to do, I'm going to consider a container of water like we have done for the pressure difference in the height we have done. No? That kind of container I'm going to assume. Okay, like this. Let's say the length is L. Pressure at this point B, P2. Pressure at this point B, P1. Okay. Let's say the cross-section area that I have taken is capital A. Now this, since this is accelerating, can I make an equation? The force, if I take this one, show it here. this whole part will be acting like this. There will be a force on the right side towards the left, which is P1 into A. Force on the left side towards the right is F2, which is P2 into A. And by Newton's law, if I take this mass as m, I can write F2 minus F1 is equal to ma. It's accelerating. It is accelerating. Correct?
Yes.
And mass I can write as density into volume, rho into A into L of this container. So I can write F2 minus F1 is equal to rho AL into A. Why I am showing this now, again, you should know the deep things so that you would be comfortable in advance. It will be P2 into A minus P1 into A is equal to rho AL into A. A you can cancel out. So you are getting a relation P2 minus P1 is equal to rho LA. It's actually similar to that relation, rho GH, that pressure difference due to height. But how to find this difference? See, if I move on to the upper one, just look at the diagram. We know the pressure difference, there is a pressure difference due to height also, it's present because acceleration due to gravity acts. Pressure, this is P naught. P1 is actually open to atmosphere, so I can write it as P naught. So here I have P2 is equal to P naught plus rho G capital H minus small h. P1 is actually equal to P naught. Can I write like this?
Yes.
Okay. So P2 minus P1 will become rho G into capital H minus small h. Rho LA. So what I'm getting here is rho I'll cancel out. H minus H by L is equal to A by G. What is H minus H by L? It's tan theta. So this is the relation I'm getting. Understood? Using this, you can find out by what height it rises up. What's the difference of the height and what's the angle it will attain. Just see carefully. I'll be selecting some question for you then. There's no good question for this. If I'm giving you a easier question, just try to solve this. Not difficult one. Just it would test your concepts. I had a very good question on this. Where is that? I have to solve this question I'm giving you. Hmm. Got it. First, try to solve this question, then try the other one.
There is PC minus PD 4000.
4000 Newton per meter square. Correct? It was actually very easy. PC is obviously higher than PD. Na? PC minus PD we have actually found out. It's rho A into this L. So it will be rho is given 10 power 3. Acceleration is 2. L is 2. So it will be 4000 Newton per meter square. What's the second one?
The 4000 root 10.
Second one?
Yes.
No. Why root 10? You have the relation now. See, PA plus rho into G into 6 meter is equal to PC. They want PC minus PA minus PD. So just put this value in the above equation. You'll get PA plus rho G into 6 minus PD is equal to your rho into A into L. That's 4000. So PA minus PD will be equal to 4 into 10 power 3 minus 10 power 3 into what value you have taken? 10. G value.
Yes, sir, 10.
10 into 6. So it will be 10 power 3 into 4 minus 60. Correct? So it will be 56. But negative value. This how you was getting 4 root n? You have taken square root.
So L is the distance height between the points that we are finding.
C and D.
So
L is,
for A and D, I like used Pythagoras theorem.
no, it does not work like this. Actually, see, you know only two things. Pressure difference actually occurs only in the direction of acceleration. If you want the pressure difference, you can take A and G, the resultant of those two, root over A square plus G square. But again, there is a problem. It's not necessary now that the acceleration A square plus G square will be along the hypotenuse. If this net acceleration was along this direction, A net, the resultant, then you can do like this. PA minus PD will be equal to rho into A net into this hypotenuse length. That's root over 6 square plus 2 square. But for that to happen, this A net acceleration should be along the hypotenuse. Otherwise, no. Got it? This is actually the short trick that sometimes they may be using in your VMC or somewhere. But there are actually circumstances, means you have to understand it properly. Acceleration, the net acceleration has to be along AD. Then only you can apply this. Otherwise not. Or it's go by the simple way, because the pressure difference occurs only along the acceleration direction. One acceleration is downwards, one acceleration is forward. So the pressure difference equations you'll apply like this, right? Like this. This one, yeah, there is this one. Understood? What about you, Haripriya? Understood?
I did till PC minus PD.
Mm. So from P, for finding out the relation with PA with PD, you have to apply this. PA plus rho G into 6 is equal to C, PC. Acha, this is okay. Now try to solve this question.
What is it? G by 3.
No, it's 2G by 3. Deva, are you getting? Hey, let me solve it. The open cubical tank was initially fully filled with water. When the tank is accelerated on a horizontal line, it was found 1/3 of the volume of water is spilled out. Okay, let's draw it. Hmm. It was fully filled, but what happened? One third of the water was spilled out. So what has happened? Out of its total volume, this much water is gone. This much water. Correct? And they say it's one third. Okay, we'll use it afterwards. Let's see. Let's take its length as L. And the difference of height is Y. Initial volume was is cross section area inside. No, 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 no. How? Initial volume was this. Let's take it as a square. I'll assume it as a square. So the length L is also inside. It will be better. Initially, and for the better, I'll take this case. Why like this? I'll take like this. Otherwise, it would become difficult to solve this question. Hmm. Initial volume Vi was Y into L square. Now, since one third of the water has the after the volume that has left, final volume is V out is half into Y into L. That's the area of the triangle into L inside. So the volume of water that has left Vi minus V naught is Y into L square minus Y into L square upon 2. That's Y into L square upon 2 delta V. And they say delta V is equal to 1 by 3 of Vi. 1 by 3 into YL square. The meaning of this, I don't know why they have given one third of the water is gone. Let's see. Acceleration they are asking. So here we know if the pressure is PB, this is PA. So we know PB minus PA is equal to rho into rho A into L. PB minus PA is equal to rho into A into L. And PB minus
Sir,
PA,
couldn't we
huh?
Sir, I consider the excess volume that's been spilled as the new height. The height it has been raised to h plus again 1 by 3h.
But are you getting the answer then?
I got g by 3.
Using that, okay. But then also nothing will change. Actually, the amount of water that is going out is from this area only. See, if you want, you can take it here.
So I consider tan theta is equal to a by g.
Correct, you can take. Actually, I was doing that only. It's rho g now. Rho g y is equal to rho al. So y by l is equal to a by g. That's that relation you can apply. So y is equal to al by g we are getting. And the amount of water that is left, yl square by 2 is cubical. Actually, we cannot take this way. We have to take that way only. It's better if we take like that. The earlier one I was telling, earlier way I was doing, na? Because we cannot take this case. If we take this case, we should get the answer that way. Initial volume, let's take the amount of water that's left. Suppose this height was y, this is L. So the amount of water that is left is delta V by L square by 2 here. Gone out. Initially, the initial volume was L cube, total volume. They said 1/3 of the volume of water is spilled out. That means YL square by 2 is equal to L cube by 3. So Y is equal to 2L by 3. We are getting the same answer. A by G is equal to 2G by 3 only. See, Haripriya, what I did, I have taken the general case, the whole volume was filled. I have taken, it's a cube. So all the length, breadth, everything I have taken as L. So the full volume of the container should be L cube, this one. And let's say the amount of water that has been left out from the container is from this height y. So this amount of water will go out, and this amount of water, if we calculate, the total volume of this was y into L square minus this area is y into L square by 2. So the delta V is y L square by 2. This much amount of water is left out, and this water that is left out, they have given it's 1/3 of the total volume of the container. So I have written y L square by 2 is equal to L cube by 3. So that's why I've got y value. Okay. But from the relation we have y by L is equal to tan theta, which is a by g. From the above relation. So y is equal to a is equal to yg by L. And y value you have already got, it's 2L by 3. So you'll get 2g by 3 only. Now tell me how you were doing. Why you are getting g by 3. Tell me.
Sir, I considered the excess volume that had been spilled as 1/3 of volume, that's 1/3 H, 1/3 L.
Acha.
I just container.
1/3 into yl square.
Yeah, I
Mm,
thought
that's
1/3.
you are actually earlier I was doing by some other way, but since you told, I started doing with by this way. But then also I think you have considered this line as wrong. You have understood this line as wrong. It's they have given
Yes, sir, I've taken
uh,
it as 1/3.
1/3 of the volume of the water is spilled out. Total volume was L cube. Out of its 1/3 was spilled out. Hey, Diva, you tell me, you understood this or not?
Yes, sir, I understood.
Hmm. Oh, I wanted to give you one more. Acha, in the next class we'll do. In the next class, I'll tell you about pressure difference in rotating liquid. You must have observed, no? Whenever you rotate something, the liquid tries to spill out from the corners. It makes a parabolic path. For that, on my YouTube, I have given one short video also have uploaded. But the liquid container, it becomes like this. The liquid surface, it becomes like this when it is rotating. So this is actually a parabola, but this path. But later you will understand the next class how it is parabola and why it becomes parabola. Why it becomes only parabola, why not ellipse? Okay, we'll discuss in the next class. Acha, one more thing I wanted to tell you, don't leave. One more thing I wanted to give, one more concept I wanted to give you. There are cases now, means when there is a container, it's like this. We know because of acceleration due to gravity, there is a pressure difference. But what happens when the container itself is accelerated downwards? In that case, if this is P1, this is P2, so you will apply P1. P2 is equal to P1 plus rho into G minus A into this height h, like pseudo force we do. If the other case was there, A down. If A was upwards, then P2 will be equal to P1 plus rho into G plus A into H. This is when the container itself is accelerated downwards. Why it happens? Because in that case you will have to apply the pseudo force MA to make it stationary, and when you are making the free body diagram, MA will act upwards. That's why you get this relation. When container is accelerating downwards, this relation. When container is accelerating upwards, this relation. Okay, this much. Rest, if I get the question, I'll give you in the next class. Let's end it now.